Game is not that complicated. Actually, it kind of is, obviously. We can move our hero around. Nope, we can't. We need to start the game first. So I have a little button up here where you click start. As soon as you start, you can start moving your hero around, and we have 10 seconds to capture as many monsters as we can. We're moving them around, we catch, game over. Whenever the game is over, we can no longer move our hero, and we got a little pop-up over here, a little rectangle, as well as some text, okay? I want you guys to know that you guys can always open up your DevTools, look in local storage in this case, and just delete the key, okay? Delete the key that we need to manipulate. I'm gonna delete it, refresh, and you guys will see that everything seems okay. And once again, what? I cannot play the game until we click the start button. So just go ahead and click start. Let's look at these values. Let's click start. And we see that we get some initial state, as well as we can move the user around. So right now, I didn't sign in, and I just gave us an anonymous name, and the time is about to run out, and you guys will see that who has our high score? A guy that's anonymous, user is anonymous, and they have a score of 3, okay? I may get yelled at for showing you this, whatever. So let's go ahead and refresh the page. Now we're gonna sign in under Primetime Tran. We sign in. So now as soon as we sign in, we can start playing. And you guys will see that as I capture monsters, right? I got 3 now. The high score is 3. If I catch the 4th monster, the high score is now replaced, right? So my high score has been replaced, and I've caught 4 monsters, right? And if we look at our top scores, we can see that we have 2 scores right here. So anyway, let's just go ahead and get started. So I'm now going to move out. I'm going to open up GitHub. Let's say courses Canvas. We start Canvas. We can see the Canvas starter thingy from Coder School. So I'm gonna go to GitHub. I'm gonna get this link right here. Jump back into terminal, and we're just going to run our git clone. We're gonna say template monster catch. Okay, so we're cloning the project. Now we can move into the template project. Let's go ahead and open up our code editor. And this should be familiar, guys. We just looked at this yesterday, okay? What are some of the things that we're gonna see in here? We look inside of game. We can see that we have all these variables that we have some default variables up front. We're setting up this thing called CTX. CTX means context. I didn't talk about this much yesterday in class because I think, in my personal opinion, you guys are not going to be working with Canvas that much in your professional careers, but very soon in your professional careers, as in like 2 weeks when we work in React, we're going to be playing around with this idea of application state. So this is what I want you guys to manipulate. I'm advising you to, okay? I want you guys to start thinking of your apps this way, because this is going to become a fundamental concept in just a couple of weeks, okay? So let's go ahead and just start our application and see what we have. So we start it, and we have the default template. Remember this one, guys, yesterday when we started? We have a hero, we move too far right, then he goes off the screen. The same is true for left or top and bottom. Okay, so let's go ahead and fix this, and we'll refactor as we go. So remember, our technical lead went ahead and gave us some instructions and as well as some comments. So I'm gonna delete them as we go. So once again, I said that you guys can just console log the hero X. So if we open up our console, and we can see that our hero X is that on the X axis when the game first starts, the hero is at 256. As we move left, the hero X gets smaller, right? And then once we go off the screen, it becomes a negative number. So in order to fix this, all we have to do is introduce another conditional. We say if hero X is less than or equal to 0, then we're gonna move hero X to 100. And what behavior will we see if we do this, guys? If we move it past 100, what's the expectation?
It's going to jump to 100.
It's gonna 100 pixels where?
On the left.
No, if we move him off the left, right? So let's think about this. On line 113 through 115, we say, hey, if the hero's X is less than or equal to 0, we're gonna move it to 100, right? So what's it at right now? It's at 500 when he's on the right side of the screen, he's on several hundreds, right? We're at 400 something right now, right? 386. We're standing there, he's still at 386. Move a little bit to the left, the number gets smaller. And as it gets smaller, he's moving further and further left on the x-axis, right? So once he gets to the x less than 100, we're gonna move him back to 100. So he's gonna be about where he is right now, he or she, where she is right now, on the x-axis, right? So that's not what we want, kinda. It's kind of what we want, but not exactly. We want him to move further. So in order to do this dynamically, because we don't know how wide the screen will be, we're just gonna do canvas.width. So we're gonna move him left now, and then he starts appearing on that side of the canvas, right? So let's perform the inverse. Now when we move to the right, we need to fix that. So we're just gonna copy this conditional right here, except we're gonna change the value, one value. We're gonna say if the hero's x is greater than or equal to canvas.width minus 10, then we're gonna set them back to 0. We save it, refresh, move left. Oh shit. Hold on. I forgot what it was exactly. Wrap around. If the hero's x is less than or equal to 0, then we set it back to canvas.width minus 10. Minus 10, my bad, right here. Sometimes you gotta play around with these values. Okay? So I'll move left, he appears on the right. If I move right, he appears on the left. Okay? So we fixed that problem. So now we're just gonna do the exact same thing except for the other ones, obviously. So we're gonna change this to hero y. And obviously we need to do a little bit more. We're gonna say this is canvas.height. Okay? And I suspect that this should work. So let's go ahead and test. We go up, he appears on the bottom. We go down, he appears on the top. So this is how we did the wrap around. This is called wrap around. So you guys will notice that our update function is getting quite long, right? We're checking what here? What's this first part checking, guys?
You're checking where your keyboard's going. Like you're defining how your player's going to move.
Exactly. We're looking at what key the user is pressing. If it's key 38, we'll move the keys. We'll move the hero up. If the key is 40, we move the hero down. You know, obviously everything, same thing that we said. So once again, I told you guys the idea behind programming, one of the most important concepts is that we want to break up our code into little functions, as many little functions as we can, right? And I remember telling you guys that like some of you guys started trying to extract out code too early, right? Too early before you had a very good mental image of like how this code works, what it does. So I'm gonna tell you right now, I can see three functions that we can extract right here. So all these four conditionals on line 99 through 110, these all have to do with movement, right? How the player moves. So we're going to define a new function. So we're just gonna define a new function. We're gonna call it move, okay? And we're gonna put this conditional in here, okay? So now we moved all this code out. We can simply replace what we have right now inside of our update. We'll call it move, and there we go. So now you can see that our update function is becoming more easy to understand. You can think of it that way. You guys want to have as many little functions as you can, okay? But this is very clear. So now when we're updating our update function fires, we're constantly checking to see whether or not we should move our hero. So let's refresh and let's see if it works. It still works, right? We're still working. And I think everything still works. Okay, so now this code right here on line 107 through 118, this also can be extracted. What does this code pertain to? Yes, this code is checking to see whether or not we should wrap the hero around the canvas. So we're going to define another function. We're going to call this one wrap around. We're just going to paste everything in there, and then inside of our update, we can simply call that function wrap around. Okay. And then here's another description. We say, hey, have we touched the user yet? Have we touched the monster yet? So this will also be another use case for a function. So we say function check if monster caught. Okay? And then we're going to extract out all this code here. Paste it in here. Paste here. And then this code, remember, this is the one I showed you guys here, right? This code, basically, we have a comment that says it, but I'm gonna advise you guys right now. If you guys are commenting in your code, you guys have probably already did something kind of wrong, a little bit, to be honest with you. What's wrong here? The code should say what it's doing. The code should tell you what it's doing. So what does that mean? On line 122, 123, 124, 125, that's a little bit of math, right? It's just a little bit of math that counts the monster size and the hero size, and it's just basically saying, are they close enough to be considered that the monster has touched it yet? The reason why we need to do this is because if you guys look closely at our move function, every single time we press a key, we're moving the hero by 5 pixels, right? So the reality is that the hero is actually going to, depending on where we randomly place the monster, sometimes the hero can never ever touch the monster. Think about it, right? So if the hero starts off on a 0, right? If he starts off on 0 by 0, right? Can he ever touch a 3? Right? Look at it right here on line 89, 92, 95, and 98. The hero is only ever on a 5, right? So the hero can only be on 0. On the x-axis, the hero can only ever be on 0, 5, 10, 15, 20, 25, and so on and so forth, right? So that's why partially why we need to do this right here. Because when we randomly place our monster, if the monster lands on a 3 by 3, even though when we look at it on the computer screen, we can see that they're like very, very close and they're touching, the reality is that the computer will not acknowledge that touch. Does that make sense, everyone? Does anyone have any questions? Okay, so just trust me, that's what this does. So we're gonna extract this out, and we're gonna define a new variable so that we don't have to read this comment. I'm telling you right now, reading a comment like this, okay, so like this is not a good example because Charles has written this comment for us as students to learn. But I'm telling you, in production code, you should never ever be writing a comment that explains what something does. It can explain why we're doing it. And you guys aren't gonna understand that right now, so just trust me that this comment right here is not a good comment for a production code. Because it's just simply telling us what it does. But the reality is we should have a variable that is telling us what's happening, right? So the variable is going to be what? Const hero caught monster equals all this stuff right here. So we're going to copy it. And now our conditional on line 123 becomes much easier to understand, right? If the hero has caught the monster, then what? Then we need to do some stuff, right, guys? This is why I'm talking. I encourage you guys to keep thinking about this as state, okay? So if a hero has caught the monster, what should happen in the game, logically speaking? We gotta at least update the score, at the very least. Obviously, there's gonna be more than that. If we've caught more monsters than the top score, then we should update the score, we should update the game history, but let's start small, okay? Let's start very small. Let's just update the score. So if we jump over here and we check score, we search, you guys will see that we do not have any variable defined that's called score, okay? So it's up to us as the developer to define new variables, just like we can define new functions, okay? We define new functions when we need them. We can define new variables when we need them. Does that make sense, guys? Okay, we're gonna define a new variable. And actually, I don't like the way this code is, so let's just go ahead and start refactoring right now. I personally want to have all my variables at the top so that I can understand the code better. So I'm gonna extract this out. We're gonna move this out right here. Let's go ahead and just start deleting these comments. You guys can always get the comment again easily, okay? All you gotta do is clone it again. So we're gonna delete this. These are explanations for what's going on here, okay? Yesterday, I had Steven mention that we see var in a couple different places, right? The reason why this is because the code that we originally got this from was old code, written like 5 years ago. So as we're pros, we're just gonna refactor as we go, okay? This will get you brownie points. In English, we call it brownie points. It means that it's gonna make us look good to our boss, okay? So we understand this between var, let, and const, and we know that we can refactor this. So now I can see that, wow, what's going on here? What did I break? Or did I break something? Okay, what did I do, guys? What did I do wrong here? The problem, the reason why whenever we're touching the monster doesn't move is that we extracted this logic out for inside of our update function out into a different function, but we did not call that function inside of our update. So we need to constantly call that function. So now I suspect when we move, when we touch the monster, it should jump. And it does in fact jump. Okay? Okay, so now we're just going to go ahead and define a new variable for whenever we touch the monster, okay? And what's the thing that Bitna showed us yesterday? Math.random is what? And then we'll just say times what? Math.random times 500. Okay, is that good enough? And then we do math.floor. Math.floor. We'll stick this in here, okay? So we don't know what this does. Remember, we can just copy it, go over to our browser, and just test it. So you guys can see that this will generate a random number between 0 and 500. So we're just going to replace this one right here for our monster X, and we'll do the same thing for our monster Y. So this will randomly produce a new location for the monster, okay? So we're going to save it, and we're just going to see what happens. I think this height should be 480 now that I think about it. 480. Let's just say 470. Be safe. So now my hypothesis is that if we touch the monster, it just randomly goes somewhere off the screen. And did we see that, guys? Nice. Okay, so what was the second go that we talked about? Score, right? So we need to introduce a new variable. So as we're working, we're thinking about our code, we're refactoring, we define some new functions, we're deleting some stuff we think is unnecessary. I'm gonna copy this, delete this. I'm gonna move all these variables to the top. I'm gonna find them right here. Okay, so we're moving this. This is just how I like doing it. You guys feel free to tell me that I suck. That's cool too. And then, so now we can see at the very top, we have all our variables defined, and it's much easier to think about like all the different things that we need to do right here, right? These are all the variables that we're going to be manipulating. We're going to delete all this. Okay, we save. We check if the monster is caught right here. Okay, so I think that's good to go now. So now we need to know, check if the monster is caught, right? We have a function which is responsible for what? One thing, checking if the monster is caught, right? So inside of this function, we're gonna do what? We're gonna increase our score if the monster is caught. And we do not have a score that is defined, so we're just gonna do let score equals 0. Oops, 0. Okay, and then we can see that whenever we capture our monster, why do I have a warning here? I accidentally deleted something, guys. No one help me, someone help me. Okay, there we go. I accidentally deleted this. Okay, so inside of our check if monster is caught, if the monster is caught, we randomly place the monster, and then we update the score by 1. Okay? So let's just go ahead and console.log the score just to confirm that this is what's happening. So score. Let's go ahead and define the variable at the very top. Let score equal 0. And just test our behavior. If we touch the monster, the expectation is that we should see a console log in the bottom of the screen. Okay? So let's clear it, touch it. Okay, so we got the score right there. Nice. Okay, so right now we got the score showing up in the console, okay? But we need to do more than that. This is not good enough. We need to tell the user somehow. So you guys can stick it on the screen inside the canvas, that's cool. But once again, like I said, man, this is just my personal opinion. We're not gonna be using Canvas in this class anymore after this lab, after this exercise. So I want you guys to work on the HTML part, in my opinion, okay? I see that some of you guys really want to learn Canvas. That's cool. I respect that. I'm not going to be mad at you if you don't do that. I'm just trying to tell you, I want you guys to do it this way because this is what you guys are going to be needing to know how to do soon. Okay? So now we're going to have an H1, and it's going to look like shit. I'm going to say hi. then we can see our high right here. So inside this H1, we're gonna say score. Now we're gonna just put this inside a container, and we move our H1 up. Then we're gonna have H3 here, and this one is gonna be of ID score, current score. Okay, current score. Save it. Save. So, what's gonna happen, guys? What are we gonna need to do with this H3 right here?
Say it and then your ID.
Yes, and then what are we gonna do inside of there?
Return the current score.
Yes, we're gonna say, hey, get element by ID, current score. We're gonna stick in the inner HTML. We're gonna say that is equal to the score. Okay. So now my expectation is that when we capture a monster that scored, there should be a 1 that appears. Is there? And then we capture it a second time. Yes, and then the second time, yes. It keeps going. Nice. Okay, so in order to test our applications, I want you guys to know it's okay to like hard code for a little bit, right? So 30 seconds is a very long time to test the behavior of the game being over, okay? I'm gonna switch this to 5. Fuck it. There's no one who's gonna stop me. This is my app. I can do whatever I wanna do. So we switch it to 5. Now we're seeing that every single 3 seconds, this thing goes up. Or the time goes down, right? Yeah, the time just keeps going down. This text is very small. I'm gonna show you how to do a little bit with CTX, okay? Or with a context, right? We're just gonna go ahead and figure out how to draw something smaller. So I think the command is CTX, font size. Okay, font is equal to like 25 pixels. Can we choose the font here as well?
Arial.
Okay, I'm gonna do Roboto. Okay, we're gonna save it, and we can see that's kind of big now. Okay, so now the question becomes, how can we stop the game from occurring? Once the user has gotten into negative numbers, how can we fix this? Okay, so how can we determine whether or not the game has gotten to 0? So we can see that we have a variable defined already called elapsed time. So we do console.log, and we'll just look at it, guys. We gotta constantly look at our variables, okay? We'll refresh, and what is the variable? It's 1, 2, 3, 4, 5. Okay, so we'll just say if elapsed time is greater than or equal to seconds per round, I think it's called. I forgot, to be honest with you. Seconds per round. If the elapsed time is greater than or equal to seconds per round, we will simply return, okay? And just know that return in this case, it means basically like exit this function. What is this function that we're in on line 100, guys? What is it? Update. Okay, so where does update begin? Where does it end? It begins on line 96. What line does it end? Okay, so if we exit early on line 100, what 3 functions cannot be called? Is it impossible to call these functions? Yeah, it's impossible. We cannot. If this is a true statement, we can never ever execute there. Okay, so I'm going to prove this to you. Console.log before line 100, before line 102, and then we're going to say after line 102. And the expectation is, I guarantee you, this is what you're going to see. Okay, 101. So when the game has just started and the time has not elapsed all the way yet, we're going to see both of these, okay? We're going to see both before line 101 and after line 101. We're going to see them constantly being refreshed in the console. But after the time has elapsed, we're only going to see line 100. So refresh. Whoa. Let me think about it. Is this true? I'm confused.
Yeah, you still render the time to the screen.
Yeah, but I want to see only... Oh, yeah, so this is the behavior I expect. Look, do we see after line 101 anywhere?
No.
Right? That's what I'm expecting. 'Cause think about it. Inside of our update function, when the time is greater than 5 seconds that we defined inside of our seconds per round, then we exit early from the update function. So that means that line 102, 103, 104, 105 can never ever execute, right? Did we prove that on line 102? I don't see an after line 101. Does that make sense, everyone? So sometimes we need to exit early. That's what we're doing. We're saying exit early based on a certain condition. And this condition is going to be whether or not the user has past the time, right? They passed the time that the game is allowing. So let's go ahead and delete as we go so that we can make sure that our console is clear and we can understand what's going on. Okay, so what did we do today? We've moved off the screen. We fixed that behavior. Sometimes my key doesn't work. Okay, my bad. It's because I ran out of time. So we can see that we moved around the hero and we can capture the monster, okay? What's next, guys?
Stop the clock.
Start the clock?
Stop or stop.
Stop the clock. Okay, so we can see that the time right here is continuing, right? So I'm going to tell you right now the render function, once again, please keep in mind this word. This is going to become huge in React world, okay? So you can see that the time right here, we're saying, hey, at the very end of the render function, like on line 115 and 116, we're basically drawing something on the clock, okay? We're saying, hey, just put something on the screen. This is all this is doing. Put the background on the screen, put the hero on the screen, put the monster on the screen, put this text on the screen, okay? So this fill text right here, we need to draw this conditionally. Conditionally render line 116. So what do we do when we do a conditional, right? What do we need to do? We gotta have an if right here. So if something, else something else, okay? So we're gonna say if what, guys? If what here? So if elapsed time is less than or equal to 5, then we'll do this. Otherwise, we'll say game over. I think that works. So one of these is going to be game over. I don't know. Sometimes we just say experiment, okay? So we're going to say refresh. We see our elapsed time. It's moving. It's moving. It's changing. And then what happened right here? Whoops. Okay, so now I don't know what's going on. Let's just go ahead and test right here. We'll test what the value is. True, 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 true. After.
Get rid of the seconds per round.
Okay, seconds per round.
In the conditional.
This one you mean? This one here?
Yeah.
Okay, let's save this. Let's just see. This needs to be false eventually. After 5 seconds, it should be false. So thank God Steven is here. Okay? We're gonna copy this one. Thank God we're listening. It's okay, man. Sometimes, even if you guys are junior developers, just exactly what just happened. Guess what? I'm a senior developer compared to you guys. But sometimes I'm thinking about 50 other things, and I need help sometimes. That's why I told my CEO, you need to give me money so I can hire someone else to help me. And that's okay. That's why I don't want you guys to be perfect. I want you guys to try your best. And if you don't need to solve every single problem, just solve some problems. Okay, just solve a couple problems and be someone that can support me. I don't need you to just fix all the problems because when I say I'm just pretending I'm your technical lead. Because I've been in that position. I'm not bragging, but I've been in a position where the boss told me we need this built. Okay, you're gonna choose some people to hire. You make the decision. I got 20 applications, Lloyd. You decide who to hire. I don't need you to be able to build everything perfectly. I just need you to help me in certain situations. Okay? So right now on line 117, we're checking to see whether or not the time has elapsed. If the time has elapsed, then, okay, no. So now we need to say, this is a bit confusing, right? So let's just say const, what? Const still has time on clock, okay? So if this is true, that means the user still has time on the clock. If the user still has time on the clock, then we should draw that time on the clock. Otherwise, we should say game over, right? So we'll save it, we'll refresh, we'll play around for a little bit, we catch some monsters, we're out of time, and now we cannot move, and we see that we do in fact have game over. Okay, guys? Okay, so now we're gonna do one more step. Okay, we're gonna do one more step. So now we need to introduce this concept of getting the high score and replacing the high score, right? So I'm gonna do this the simplest way, and then I want you guys to think about how to do more sophisticated behavior. So we're gonna look at our index.html, and we're just gonna copy over this container, except this one is going to be high score, okay? And we're gonna say current high score, okay? We save it, we refresh. Okay, so at the very top of our application, we're gonna define a new variable, and we're gonna call this one application state. We're gonna say const application state. So I'm going to tell you the more advanced technique right now. Okay, I'm telling you right now so that you can solve a bunch of problems. Okay, so we want this available, and then we're going to manipulate this thing in the future. Okay, but in order to solve a bunch of different problems at once, I want you to go ahead and get that application state from local storage on this line. So we can say local storage dot get item. We're going to call it app state. What if we do not have this defined, guys? What's it going to give us? So it's going to give us a null. Okay, so if we run it, do I have something called app state in my local storage, guys? Oops, I did this wrong. Okay, let's refresh. Do we have something called app state here? No, it returns null, right? There's nothing. There's no key in here called app state, right? So what we're going to do is we're going to test it some more. We're going to copy this, and we're going to do JSON.parse, and we're going to pass it this thing right here. This also gives us null. So what if we have null or true? What does that give us? So what if we have null or high? That's going to give us high, right? We've had null or console.log test. It's going to console.log test. So basically, this is what we call a logical operator. We're saying, hey, if this thing on the left does not exist, give me the thing on the right. If the thing on the left does not exist, give me the thing on the right. So watch what's going to happen. We can also do true, remember true or false. And it gives us true because the thing on the left is true. So what if we did high or go? It gives us high. Okay, so we're checking to make sure that we have the thing on the left first. If we have the thing on the left, we'll take it. If we don't, we'll take the thing on the right. Okay, so it's a logical OR operator. So how does that apply to what we're about to do? What did we just do a second ago? We're saying, hey, give me local storage, get item, app state. Okay, and I'm going to take this bad boy. Why can't I see this? Okay, I'm going to take this bad boy, and I'm also going to parse it because I want to go ahead and run everything on one line so we don't confuse ourselves. So we're going to do JSON.parse, JSON.parse this thingy right here, or an object. So what are we going to get if we hit enter right now, guys? Yes, we get the object right here, okay? So now we can just copy over here. We're going to go up to our application state, and we're just going to say, hey, the application state, when the app first loads, either get what's inside of local storage or give me this object. And this object is going to be indicative of something, of our scores, right? So we can say current. Fuck, man, I don't know if I should show you this. I'm just going to do it.
Do it quickly.
Yeah, I'm just going to do current high score.
Show us another way. Did you start it now?
I just want you guys to know. I want you guys to know that every single day I go home and I talk to my boss and he tells me what he wants me to do, what he wants me to not do, okay? So I want you guys to know, don't do too much. Don't show objects, blah, 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 blah. And I trust him. I do trust my boss, okay? But I want you to know I'm showing you more advanced stuff, and this can all be done simpler, okay? It can be done with more simple concepts, but you're gonna have to write more code, okay? So I'm gonna show you right now this for those of you who are doing well. We're gonna just do a current high score, and we're just gonna stick in a 0, okay? So now, let's look at our application state. I'm gonna show you one more function, 2 more functions, okay? So to manipulate this, to get things into, so the idea here, right, is that when we have a game right here, right, let's refresh it. When the page first loads, right, we should see right here where it says high score, we should see the previous high score. Anyone who has played the game, we should see what their score was, right? So now you guys will notice that also, let's first just move the hero around. If I capture it, we don't see any high score here yet, right? So now we need to fix that bug first, right? So how can we get the high score? We can define a function called get app state. This is going to return JSON.parse. We're gonna parse something. We're gonna translate it, okay? And we're gonna translate something called local storage.getItem, and it's gonna be called app state. Okay? We save it. We save it. We refresh. If I call this function, you guys will see that it's null. Okay? It is null right now. The reason why that is because we don't have anything inside of here. So we need to do the inverse. What is the inverse of taking something out of local storage? Saving it to local storage. So we're going to define a function called save, and inside of this we're going to do local storage.setItem. We're going to name it the key app state, and then we're going to say JSON.stringify. This is basically going to say, hey, make this savable. Okay? So inside of our app state function, we're going to pass it an argument of app state, and then we're going to stringify this app state, and then stick it inside of local storage local storage. We're going to stick it inside of the local storage inside of a key called app state. So what is the one condition right now in which we're going to run this function save?
When there's no previous store, is that right?
Really close. It's when we've touched the monster, right? So we check if we caught the monster. This is on line 99, this is where we've caught the monster. Now we need to perform some additional logic right here, right? We need to say, hey, we need to get the current state of the application first, right? We need to determine what is the current state of the application. So we're gonna say, hey, we're gonna say const app state is equal to, what's the function we just defined, guys? Get app state. We're gonna call that function. Call that bad boy, okay? And before we move forward, let's just look at it. What do you guys expect to see inside of here? What's gonna go inside? What's gonna be inside of app state? It's a function. What's it doing?
You set this. See, current high score equals 0.
It's gonna be an object, and it's gonna be an object that we get from local storage, and then we're just gonna manipulate it. So let's just test. We refresh. We move. Oops, my bad. We move. Did we get it? Oops, did I do this wrong? It's null. So the problem now is that we have not saved it yet. Okay. So now we got to say, hey, in what condition do we save to that high score? Okay. So we need to say, okay, if app state is equal to null, what are we gonna do here, guys? Say again?
Second.
I'm actually a little bit confused on it. Hold on one second. Why is this not working? Local storage, I get item. One second. Okay, I did this wrong, my bad. I tried to do two different things at once. Delete this one. We're gonna do this inside of this right here, okay? Or here, okay? So now my expectation is if we catch it, we should see an object that has one key. And do we see an object that has one key? Right? My bad, I kind of did it two different ways at the same time. So on line 104, when we have caught the monster, we call our function getAppState that returns something for us, and we stick it inside of a variable called appState. The very next line, we look at it. Can someone tell me a superhero? What is a superhero? Hui. What's a superhero? Tell me a superhero.
Superhero lady.
Tell me any name a superhero. Batman. Someone name a color. Pink. Okay? So I'm telling you, when we see pink Batman, right, it's going to come from line 104. I promise you. It can come from no other place. So we're going to refresh it. We're going to refresh it. We're going to touch the hit monster. And we see Batman pink. Okay? And what is console log next to it? It's an object. And that object has one key, current high score. Okay, guys? So we've proven what is inside of appState, right? So we're going to say, hey, what are we going to do, guys? Come on. We just need to perform some conditional logic here. AppState dot. Let's look at it. That current high score. Okay, so what's the condition we want to do here? If the app state dot current high score is less than score, then what do we want to do?
Display current score.
App state dot current score is equal to score. And then what do we need to do? One more step now, guys. Save. Thank you. Save it. That's all we gotta do. And the reason why I'm showing you this is because I've seen a bunch of you guys. You guys have local storage calls everywhere, all over your apps. You're like, in every single function, you call local storage, you get item, parse, blah, blah, blah. The reason why I'm showing this is I want you guys to only run JSON parse, JSON stringify in one place. That's the best way to do this, I guarantee you, okay? So now my hypothesis is that when we refresh this bad boy and we touch a monster, we should start seeing stuff in here, okay? Oh, my bad. Save it. Do we see a current high score? Let's refresh it. I guarantee you I catch it twice if we replace it. 1, 2. Look how the high score updates. Okay, obviously this object is very simple. It has one key inside of it. I want you guys to do more. Okay, I want you guys to add a current user. Give me a current user. Attach that current user to a high score. I want you to also have this object have keys. Another key. So for example, you can say game history is this array, and then we're gonna have a current user is gonna be what? Document dot get element by ID, username, or anonymous. Okay, so this is in this case we can never ever have a not user. Okay, we're always going to have either a user or a anonymous user. Okay, it's one or the other. Okay. All right, guys. So I've been talking now for 41 minutes. I want you guys to work on this, and I want you guys to think. But before that, I want you guys to ask me any questions. Does anyone have questions about what we've done so far?
Can you explain me the JSON part?
So JSON.parse. Okay, let me show this. Guys, the thing about programming is that like we really wish all computer applications could talk to each other very easily. Just like I wish I could fucking speak Spanish, you know? But I don't. I don't know how to speak Spanish. I took a class, I got an A in it. But that was like 10 years ago, okay? And I haven't practiced Spanish. So JSON.parse is a way that we can translate. You can think of parse as almost like translate. Translate this data. So let me show you. So right now, if I did let's do local storage dot set item. We can stick in something. Let's just say Ricardo, and then we stick it in an object right now. Well, first off, we need to translate it before we stick it in. We say JSON.stringify, and we'll stick in an object and it's going to be name Ricardo, country Chile. Okay, nice. Okay, so now we can see that inside of our key, inside of local storage, we have this key called Ricardo, and we have this object right here. And so what if we, like, it's not useful to be able to put something inside of local storage unless we know how to get it out, right? So normally, if we have an object, let's say const school is an object, name is coder school, right? Can you guys see this? I'm a little scared right now. Can you guys see this?
Zoom a little, it's a bit better.
I'm trying to help you guys see everything. Okay. So we have an object, school. Who here thinks that school is an object? Who here agrees with me? Okay, so what if I wanted to get the name out of school, what could I do? School.name. That works, right? School bracket name also works. Okay? That's cool for a JSON or JavaScript object. I get school right now is a JavaScript object, 100% right there, right? But what is inside of here? Is that also an object?
Strings within the object.
Yes, okay? So now let's just think about this, okay? We'll do type of local storage dot get item. What's the key? Local storage dot get item. This is giving us a string. Okay, so as it's stored in there, it's like, yes, it's showing you that this is an object, right? But right now, it's formatted in such a way that it is only a string, okay? So if we run this again, except we run JSON.parse, we now see that it is in fact an object. So we can manipulate it, right? So think about this. If we do this right here, we copy this bad boy, which is a string. Can we do JSON? Can we do, what's something that you can do on an object? Name? It does not work, right? But now if we do the same thing right here, we copy this one where we parse it and we run it and we do .name. That does in fact work.
And how do you implement it on HTML?
Implement what?
Like the JSON parse?
To get Ricardo showing in HTML.
So right here, just know that like we implement a function called getApplicationState. It already parses it. We parse it in exactly one place. I want you to do it this way. If I do Command D, I don't see this anywhere else. Please do it inside of a function, and this function's only responsibility is to do what?
Turn your strings into objects.
No, this function is to do what? Just read the name of it. It's to get the application state. And right here we have an or operator because we say, hey, if I can't find application state inside of our local storage, let's go ahead and give it some default state right there, okay? So really that there's a couple different responsibilities of this function right here. Please look at the current state of the application and give it to me. If it does not exist, go ahead and give me some default state. That's what we're saying right here, okay? And when we look at our current application state, we're looking at the local storage, we're looking at a key called app state, and we're also parsing it so that we can manipulate it. Because remember what we looked at a second ago, right?
Just go back there. So your default state is defined by those three: game history being an object, current underscore being 0, current underscore being
So when we call,
or anonymous.
yeah,
That's your default.
yes.
Yeah.
So if we do not have a key in our local storage called app state, we're just gonna have this thing that we have highlighted, right? And that's going to save us. That's gonna protect us from a lot of different situations in which we're like, oh, I'm looking for a top score. I'm looking for a top score. I don't have it. I try to call it and it throws an error. So if you do, like for example, if you guys did null.name, it's going to throw an error because you cannot throw .name. You cannot call name on null. And like I said, you guys just have more practice. You know, like null is something that like null means nothingness. It means almost like nothingness. I don't have any value there. I couldn't find that value. So if I have nothingness, if I ask nothingness its name, then you know what can you guys say, right? But if I had a person, right? If I had a person and I said, give me your name, then you could say something. But if I said, give me the person's name in the phone whose phone number we could not find. So what if I gave you guys a phone number, right? I said, guys, okay, guys, I got someone whose phone number is this right here, right? Can you tell me his name? No, right? Because you couldn't find that person. Let's just pretend you couldn't find that phone number. I'm saying find that person that has that phone number. If you cannot find that person, give me their name. So like, if you could not find that person, could you give me their name? It's impossible, right? So the computer, that's exactly what they're trying to tell you. That if you try to call a name or any method on something that is nothingness, then it will throw an error. It will complain and saying that you can't do that, man. You cannot do that. I'm not that smart. Okay, so I hope that cleared it up for you? I hope that cleared it up. Do you have any other questions, guys? Okay, so I'm gonna let you guys think about this a little. Please try to get, I know that we gave you guys a bunch of different examples of different apps that you could build. Yes, I want you guys to be creative and have fun with this. But please, at the very least, before you start trying to build the next asteroids or the next Flappy Bird, try to get this minimum viable product working, okay? This is the minimum. This is the simplest you can build this app. Well, obviously you can build it simpler. You can build it like, I don't know. Remember how when it first started, you could only move, the monster only moved, to the right and it couldn't go off the screen? It could be simpler. But I want you guys to, at the very least, build this right here, okay? Show me a score, a current score. Show me a top score. Let the user have game over, right? If the user runs out of time or whatever, and then keep track of your previous scores. Okay? I promise you guys this will become more valuable in the coming weeks. Okay, guys?